when it comes to the list interface, there are two implemented classes which we are going to discuss. So what are those? One is array list and another one is a linked list. What is the difference between these two? When we should go for array list and when we should go for the linked list? What is the list interface property? List allows duplicates or not? List allows duplicates, and it is also an ordered collection of elements. Then when we should go for array list as an implemented class and when we should go for linked list as an implemented class? In this array list, duplicates are allowed. Array list allows duplicates. Yes, here also allows duplicates. What about linked list? Linked list also allows duplicates. Next, what is next property? What is the internal data structure support? Along with most commonly implemented interface for every collection class are serializable and also clonable. So along with that, there is one more internal data structure. Random access is the data structure support. And what is the interface which will be implemented by this array list and also linked list? Interface I'm asking. What is that marked interface name? Interface name is not marked interface. Random access. Because index based operations are possible on these two, therefore it needs a support. That support will be provided by this random access interface, and because of no methods present in this interface, we call this as a marker interface. Because of no methods, random access interface is also called as a marker interface. Definition of marker interface is nothing but an interface which doesn't contain any methods. It is an interface with no methods. Then it sounds like it is strange. The interface is the support, but no methods are there. So who is going to do that? Is JVM will provide all the required things. JVM will provide all the required things, but as an interface of this random access has no methods. Because of no methods, we call it as a marker interface. Comes to the internal data structure support for this array list is nothing but data structure support, random access interface. What's the support here? What is the support? Array list is a class name, not the internal support here. We discussed in the last class. What is support for this linked list here? So here it is a doubly linked list. Yeah, and here the random access and one more interface support is there for this. Because we try to add extra elements, the default size is of array list is nothing but 10, and if you try to add 11th element, internal growth factor will be implemented. Because of that, the array list size will regrow from previous size from 0 to 9 to depends on the next elements that we add, will regrow from previous size to a next size. So because of this, it needs a support that is possible with help of resizable or growable. Yeah, it is for both. It is for both. And what is that default size? Default size of this array list is nothing but 10. What is the growth factor? The growth factor is nothing but current capacity into 3 by 2 plus 1. So this is what we discussed. And what is the drawback with array list or when it is preferred? array list is preferred when the frequent operations are, if the frequent operations are accessing the elements. And when this linked list is preferred, it is preferred for frequent operations of adding or removing. Yeah. So these are the points which we discussed in the last class. Anybody any questions from this? Any of you any questions from this? No? Yeah. And when we try to insert the elements into this array list, we discussed what is the problem of the shift operations, how many has to perform to be performed internally. So in the same thing, what is the problem with linked list if we try to get the elements, accessing the elements, rather only instead of adding or removing, what will happen once we get the elements? We try to get the elements, so that we'll understand with the help of this data structure support called as DoublyLinkedList. Then we'll go for the execution of these programs. First, when it comes to array list, if an array list consists of some thousands of elements starting from 0, let me take some example of say 999. I'm taking some 1000 objects in this. Yeah. What is the best choice? When is the best choice to go for array list? If at all you want to access the elements from the any of the given index positions, it is easily we can access the elements. For example, by using some array list object variable, I'm using AL just by assuming array list object is a AL there. AL dot some, if you are trying to access some index position 0th element. Assume that if you are getting the 0th index position element by using this AL, assume it takes some 1 second of time. Yeah. By using this array list object AL, and if you are trying to get some 10th index position element, it also take the same amount of time only to retrieve this 10th index position element as well, because of random access support. Because of this random access support, it is the same time we try to access 0th index element, or it is the same time it will take if try to access the some 1000th element, that is 999 position element. It is the same time. Yeah. But this is for accessing the elements. But at the same time, if you try to insert or add, for example, if I am trying to add one element into this array list at index position of say 1000, with some whatever is the value depends on the type of the array list, what will happen? The corresponding control will come to 999 position, thus JVM will internally check size is not sufficient, it will regrow, and therefore directly it will come and add the element at the 1000th position or the next position. Correct or not? So this is how any shift operations are required. No shift operations, because we are trying to add at the last index position. But assume this will take some 1 second. Assume. At the same time, if you are trying to add one more extra element or trying to insert one element at index position say 1 this time, we are trying to insert or add one element into array list at index position 1, then is it the same time to take? No, definitely more time, because all these previous elements has to be shifted into the next positions, then into that position this element whatever we are trying to add to be added into this index position number 1. Therefore, accessing is nothing but it's a common time whichever the element that we try to access by using the corresponding index numbers. But when it comes to adding or inserting at the last position, it is pretty easy. It's a less time. But when it comes to the especially starting position or somewhere in the middle, then this is a definitely more time than this last element adding. So because of these reasons, if the performance of array list will be slow, because when we try to add the elements at starting index positions especially, So because of these reasons, array list is not recommended to go for the modifications. It is best preferred to go for the accessing the elements because of index position, and with the help of random access support, it is the same amount of time it will take to access any element. Am I clear? Am I clear, guys? Next, about linked list, we'll discuss about linked list and also doubly linked list. How it is difficult or it is time taking to access them, and how it is easy to add. For this linked list, I am directly going for a discussion of doubly linked list. So internally, whenever we try to add the elements or we try to add the elements into this or linked list, whenever we try to add the elements into this linked list, it internally has the support of doubly linked list. What is the meaning of this doubly linked list is, whenever a programmer tries to add some element, then internally it will be formed like this. This we call it as one node. This node has three parts in doubly linked list. This node has three parts in doubly linked list. One is nothing but starting position, and one is the middle part, and one more is the last. If we try to add some data into this linked list, say some numbers, assume I'm adding 100. The value will be stored in the middle portion of this node. And the left node will have the previous node address. Previous node address. And the right part will have the next node address. Next node address. Example, if I take a linked list of some three elements, so here is the first node, then second node, and then third node. So here, let us assume some data, 100, 200, and 300. So this is where the middle portion, the data will be stored. Since in this doubly linked list, this is my first node, and the next one is second node, and then third node. Is there any node before first? As it is our first element, then this first portion will contain no value. That means null. It will contain null. And what this will contain? The next node address. Say for example, if I call this as 0x100, it's not same as this 100. Or let me take 1. Then let me take this is 0x2, some 0x3, and some 0x4, 0x5. I'll come to this last part. So what this will contain? If this is the address, I'm sorry. Just a minute. If this is the address of say 0x1, and this is 0x2, and 0x3, and 0x4, and 0x5. This is the address. Then here, previous node address. The left part of the previous node address will be contained by the right part of the first node. That is nothing but 0x2 will be here. And what this should contain? 0x1. Therefore, there is a linkage between these two. That's why the name is also linked list. There is establishing a link between the first node and also the second node with the help of the address. Similarly, here also what should be there? 0x4. Therefore, there is a connection is established. And here also back to this again 0x3. So like this, there is a link between one node to the another node, depends on the node address. So because of that, even the name also given us doubly linked list. Two sides there is a connection or link. That's why we call it as a one link and the other one. That's why we call it the doubly linked list. So because of this reference with one node of the another node in this entire doubly linked list, so it is very easy to add the element at a particular index position. Assume this is 0th index position first index position, second index position. Now I want to add or insert one element at first index position. Previously in array list, what has to happen? All the previous list elements must be moved to the next index position. Shift operation has to happen. Then wherever we are adding it, that element will be inserted. It's a time taking process. But when it comes to this doubly linked list, it is very easy, because if I try to add one element at first index position, then what has to happen internally is this previous connection will be disconnected. Then with this, wherever we are trying to add the first index position element, then the element will be added there, some 400. This has some address, some 0x6 and 0x7. This connection will be removed and this new connection will be established back. And here also, this new connection will be established back. So that means what this will contain now? 0x2, and what this will contain here? 0x1, and here 0x6 will be there, and here 0x7 will be there. Any shift operations are happening? No, only one node is inserted in between. This is the reason behind why linked list is very preferable to go for the insertion of elements at any particular position. Because no shift operations, simply one node will be connected with another node. The previous connections will be removed. This is how it is very simple when it comes to adding elements into the linked list because of this internal data structure support. Then what is the drawback? Accessing the elements, right? So here, for example, in this entire linked list, assume there is 100th element. 100 elements are there or 100 nodes are there. And if you are trying to access the 0th index position element by using this linked list, if I use some linked list to get in 0th index position element, assume that it takes some 1 second time. When you try to get the second element, that is index position 1 element, what has to happen internally is, when by using this linked list object, if you try to print first index position element or access first index position element, first internally JVM comes to 0th node, 0th index position node. Then based on this address, JVM goes to the next address, and based on that, JVM picks the value and gives the output as the next element. So in this scenario, how much time it will take? If first one is 1 second, the second one will take how much time? Approximately some 2 seconds. Correct or not? To get third one, 3 seconds. To get 100th one, 100 seconds. Is it the same amount of time? No. Whenever we try to access the elements of 0, 1, 2 and so on till 100, each time as the index positions are different from 0, that much time it will be taken to get the output of the value or the element. So because of this reason, internal connectivity, accessing the elements by using linked list with the help of internal support as DoublyLinkedList will take time, because it is not directly goes to the 100th index position element. It will go from 0 to 1, 1 to 2, 2 to 3, 3 to 4, like that. It will reach the last index position based on the previous node address and all. So because of that sequence of execution, the time taken for accessing the elements is more, but inserting elements is a less. That's the reason behind linked list is supported or best suited for adding the elements, and array list is best suited for accessing the elements because of this internal mechanism of how the memory works. Is it understood? All of you. Then here, since this is a starting node, I'm not writing many nodes, but I'm using the same reference here. Since this is the starting node of our linked list, this is called as some head node. Starting point we call as generally head node. So here is the head node. This we call as head node. First node is called as head node. What head node left part will contain? No value, because there is no previous node to have the address. That's why it contains null. What will the last node will contain? So this will contain the previous node address. But what about the last part? Since we are saying this is the last node, there is no next node to have the address here. That's why null. This is called as end node or tail node. So this is about the doubly linked list, which internally support linked list. We have written the points of when it is preferable for array list and linked list, but the explanation or the reason behind that is this. Just a glimpse of what is this linked list as well. When it comes to linked list also, it's the same concept only, but here only two parts will be there. When it comes to linked list, internally there are only two parts. One is the value and another one is the address. So for example, if this is the value with some address and this is one more address here. So for example, say here value is 10 and some address 0x100, 20, 0x200 and some 30, 0x300, some 40, 0x400. Because previously doubly linked list will consist of three parts of this node. That's why we have a previous node address and next node address. But here only the next node address will be there. Only the next node address will be there. That means this will contain 0x200 and this will contain 0x300 and this will contain 0x400. This will contain null because it's the last one. There is one link will be there. Only one link will be there, not bidirectional. That's why this is called as a linked list, is also called as singly linked list. Because of only one link between one node and another node, it is also called as single linked list. Again, this is called as head node and this is called as tail node. Because there is no previous node here, no null for the head node, but for the tail, since there is no next node, that will consist of the value called null. But internally, this is the data structure support that linked list has as a doubly linked list. Into this array list and also linked list, null values are allowed or not? Allowed or no? Duplicates are allowed? Yes. Can we insert null values? In a short way, when it comes to doubly linked list, DLL, I'm writing, not SQL kind of DLL. Doubly linked list. Doubly linked list is nothing but it is in the form of a node. That node will contain three blocks. First block will contain the previous node address. Middle block will contain the value. And the last block will contain the next node address. So this is our doubly linked list will be there. Then why we call this as doubly linked list is when we try to add elements into this list internally, the data structure support is nothing but doubly linked list. So since if we try to add say two elements into this linked list internally because of the doubly linked list, the values will be stored into this middle node. Say for example 10, 20. But this each of these blocks will contain some address, say 0x100, 0x some 200, some 0x300, and then 0x400, and 0x500, and 0x600. So since this is the first node, there is no previous node address. That's why it is null. And the last part will contain the next node address. That's nothing but 0x400. For second node, there is a previous node. Therefore, this will contain 0x300. For example, I am taking. And for this, there is no next node. No next node. That's why this will contain the null. So in this series, the first node is called as head node. And the last part is called as tail node. Because of this internal node structure, it is easy to add one element at some index, specific index position, because no need of any shifting operations. If you try to add one more element, internally one more node will be created with appropriate index numbers. And this previous connection will be removed and a new connection will be established. With this node address, again it will be stored here. Say for example 1, then here 1 will be there, and here 2 will be there. No shift operations are required. Because of this reason, DoublyLinkedList with the help of internal support as a linked list. Linked list is preferable for addition or modifications, but not for accessing. And array list is preferable for accessing, but not for modification or additions, especially at the starting index positions. Yeah. Now we'll go for the execution of this. Just please join back, guys.